This podcast was recorded and provided by the National Association of Regional Councils. For more information about NARC, please visit narc.org.
Hello everybody, this is Mia Colson with the National Association of Regional Councils, and welcome to another installment in our solar podcast series, part of the U.S. Department of Energy's Sunshot Solar Outreach Partnership. Through this partnership, NARC is working with the International City and County Management Association, the American Planning Association, and ICLEI Local Governments for Sustainability to support local governments in increasing solar deployment in their communities nationwide. Today I am joined by Matt Kruzmark from the Denver Regional Council of Governments in Denver, Colorado. Matt has been the Information Service Manager at DRCOG for nearly 2 years, and prior to that he was the Geospatial Program Manager for almost 3. Matt's focus and expertise has been to work collaboratively on technology and data sharing strategies with DRCOG's partners in the regions and support planners, modelers, and engineers' technologies needs related to MetroVision, which is DRCOG's flagship long-range planning effort. So thanks for joining us today, Matt.
Thanks, Mia.
All right, to start us off, for anyone who's unaware, could you give us a brief description of your role as the Voluntary Association of Governments in the Denver region?
Yeah, since 1955, the Denver Regional Council of Governments, known more as DRCOG, has served as the metro area's planning organization, making it one of the nation's oldest. Currently, DRCOG's planning area covers 9 counties, ranging from urban to suburban to rural, and from mountains to plains geography. DRCOG has over 56 member jurisdictions, which includes 9 counties, 47 municipalities, and those communities range in size from a population of as low as 109 to 611,500, which is the makeup of Denver. DRCOG is engaged in long-range planning for transportation and serves as a metropolitan planning organization, focusing on land use, environmental quality, and advocacy for the region's elderly population. DRCOG offers services ranging from commuter assistance to the recruitment of fire service personnel for our local governments. DRCOG has a long-standing role as the Area Agency on Aging and the Metropolitan Planning Organization, which is designated for our region.
So we're here today to talk about DRCOG's solar map. Why don't you tell us a little bit about the map?
Sure. The Denver Regional Solar Map was developed by DRCOG and a private sector company called Woolpert from a grant in 2010 from the Governor's Energy Office of Colorado. And the idea behind the map is to allow the public to get information about a building's solar PV potential and some related benefits or kind of next steps they can take to implement solar on their building. So from the solar map, you get a rough idea of kilowatt generation by month. You can get an installation estimate. You can get information on estimated yearly electrical bill savings if you were to implement solar. And there's also a form on the website that you can complete to request more information from the actual local solar installers. The other unique thing I think about our solar map is that it's also an educational tool. You can basically browse around the map in a really familiar Google Maps type interface and look at different types of buildings and get an idea of solar potential. So oftentimes we found that users aren't just looking for information about their building, but they're also kind of clicking around the site, looking at different types of buildings, especially if they're maybe a building, a company that owns a lot of buildings, that type of thing, just to get an idea of what solar potential might look like on other buildings as well. And I think another really interesting thing about the technology is that the data behind the map can change and changes as new information is provided into the database. So in some areas where detailed rooftop and building size information is unavailable right now, just for a lack of data, there's sort of a generalized calculation that can be used by parcel for like single-family residential, for example, that gives a rough calculation. So that provides a nice kind of placeholder in the future if we're able to get data in other areas that we don't have it right now.
From experience, I can say the map is really simple and really easy to use. So you talked about the data. Could you tell us a little bit more about the back end of how the map works, the type of technology that you used?
Sure. So for the most part, we tried to use data and technology behind that was free of charge. So we knew that if we were going to do this as sort of a one-shot deal, yeah, we could have went ahead and purchased the data. We could have purchased different technologies to implement the solution. But we also wanted to save money over time and be able to have this be implemented by organizations of different sizes and budgets as well. So all the data behind the application was data that we received from our member governments, or was data that was acquired by a special project when the Democratic National Convention was in Denver in 2008. There was LIDAR, which is light detection and ranging data, that was acquired by the USGS for security purposes for the DNC. So we were able to tap into that data as well after the DNC and use that to find more detailed obstructions on top of buildings to get a more accurate estimate for solar. So there's that data included in the core urban area. And then we gathered building footprint data from many of our member governments that had already gathered that information for their own business purposes and were willing to share that information with DRCOG. So there was a lot of building footprint data as well that went into the kind of core urban area and kind of inner ring suburbs of the Denver region. And that provides a lot of useful information to get more accurate calculations. And then outside of that, where there was maybe not building footprint that was able to be gathered from member governments and local governments, that's where we use that kind of generalized parcel calculation. So we knew that it was a residential parcel or a large parcel that could have a commercial building on it, or the potential for a commercial building. That's where we provided some more kind of rough calculations, but at least it gives people an idea of what the potential might be. So the data is stored in a spatial database called PostGIS, and that database is an open source spatial database. And the other tool that's used to speak with the database from our Google Maps interface is called Ruby on Rails. And the Ruby implementation allows the user to click on the map, the Google map, and that information then sends a query to the database in real time, and that calculation is provided in real time to the user. And the really great thing about that interface, from the Google Maps on the front end, which people are already really familiar with, to the Ruby implementation that allows us to communicate directly with the database in real time, is that the user, as we update data behind the scenes, that calculation can change. So if we're able to get new information about a building, we can enter that into our database. And in the future, if the user was to come back and click on that building again and that information is there, they would get a better estimate in the future. So that gives kind of an idea that it's mostly free and open source information kind of behind the scenes. And the only thing that we're really paying for on the front end is the Google Maps interface. And we use that for lots of other business applications at DRCOG as well. And I think the great part about that, even though we're paying for that implementation, is that the Google Maps interface is something that we all are familiar with and can use, and it doesn't require any training for the user to get familiar using the interface.
That's really interesting. So do you have any measures that would illustrate the project's use to date?
Yeah, definitely. I'll start with some of the more challenging parts of the site and some things that we're kind of learning over time. We have a form at the back of the system that basically, if you're the user, you type in your address, you find out some good information about your building, the solar potential, and things like that. But then you kind of want to take it one step further. So as all of us know that have used any of these types of interfaces, they're going to give us some type of rough calculation. It's not exact, right? So after that, if you're really serious about installing solar on your building, what we did is we set up an interface where the user can actually type information and say, hey, I want to be contacted by a local solar installer. So there may be some improvements that we can make there for the user, I think, to get them more easily connected to the local solar installer. So we're kind of learning over time about what that might look like. On the other side of it as well is that when we actually released the solar map in January of 2011, that month alone we had over 12,000 unique page views, and we had our users spending over 2 minutes on average on the site, which is pretty remarkable. So the site got a heavy amount of use right away. We had a lot of really good press coverage and media coverage of the site, and DRCOG, invested time into connecting with folks and letting them know about the solar map when it was initially released. So, but as the months kind of continued on, it dropped off the next month in February to around 1,500 page views, but it was still pretty significant. But the unique thing about that is I think a lot of those people were returning visitors because they spent even longer on average on the site. Many of them spent over 3 minutes on average on the site. And since then, as I've kind of averaged it out, we've had an additional over 6,000 more page views over the next kind of year and a half. But again, the part that we're really proud about and happy about is that the user is still spending close to 2 minutes on average as they're visiting the site, which I think is a really good metric.
Great. So what are DRCOG's next steps for continuing to support solar in the region?
So again, kind of I talked about, and this is kind of my background, is a lot of the technology parts of the solution. We built the solar map on a framework, on a software and data framework that makes it really easy to update the building and property related information, kind of as needed. And again, the software behind the scenes is all free and open source software with the exception of the Google Maps front end that we have. And again, that's used for a lot of other applications at DRCOG, so we don't have any need to find a different interface to use in the future. And the public is used to using an interface like that. So again, into the future, our communications and marketing staff right now, they're also kind of evaluating and working closely with our planners to determine the next steps for the solar map for the future. And I think there's other opportunities as well. We love talking to people about the solar map. I love to talk about the technology behind the solar map and just let people know how easy it is to implement this technology. So I'd be more than happy to work with any partners or any folks that have questions about the solar map framework if they wanted to implement their own solar map in their own region or within their own local community.
That's very nice of you. So can you tell me if there were any key partnerships in the establishment of the solar map?
Yeah, it's a great question. We connected with Woolpert. They were sort of our private sector partner in the project, and we connected with them because of their expertise in several areas. And one of those key areas is on the mapping side of things. Woolpert is known as an expert in working with LiDAR data, which is light detection and ranging data. And as I mentioned previously, the Democratic National Convention that was held in Denver in 2008 created a really unique opportunity as the federal agency, the United States Geological Survey, collected LiDAR data in the core urban area of Denver and nearby cities. Woolpert was able to take that data and process it and determine obstructions on building rooftops. And what that did for our project is it helped us to better determine placement of solar panels for installer estimates through the web-based interface that we used. The other really important partnership that we had was with COSIA, which is the Colorado Solar Energy Installers Association. And COSIA is a group of folks that have gathered the local energy installers in Colorado, and we were able to work closely with them to get more accurate calculations that were localized to our Denver region. That was kind of different than some of the other more kind of federal calculations that you're able to get through other sites and things like that. So COSIA, we were able to sit down with them and really fine-tune those calculations and get those calculations localized. And the other great thing about COSIA on the back end of our application is when you're a user and you're using the site and you want to be actually contacted by a local solar installer, COSIA is the one that provided the list of local solar installers. And when a customer asks to be contacted by a local solar installer, their information is already contained within the site, and we were able to connect up folks that wanted to get a more accurate estimate with an actual local solar installer within Colorado. So that was a great partnership as well.
So the question we always end with is there anything else you would like to share with someone interested in doing these similar projects? You said that they could get in contact with you, but any takeaways?
Yeah, I think the best takeaway for us is the collaborative parts of it. So the collaboration that we do, that DRCOG does with its member governments, I think is the most positive takeaway from this. And so I think if you're working in a region or you're a municipality that has a group of folks and really solid data that you can put behind something like this, you can do it. So really the better the information that you have behind your solar map is the better the information that's going to be provided to the user of the application. And so I think if you're able to collaborate really well with people in your region, if you're a council of governments like we are, and get that data and information behind the map, basically the message I always tell people is you can do it. It's not as hard as you might think. And again, we'd be more than happy to share our technical insights on how to get it done. But again, I think the biggest takeaway for us has been the collaboration, which just shows that when you've got a great relationship with your local governments in the region, you can do a large regional kind of application like this for literally pennies on the dollar. And again, to maintain it over time is really affordable. And as we get new information, we're able to plug that information into our database. And it's really not a very cumbersome process at all, and a really effective way to build partnerships with people.
Great. Well, thank you, Matt. It's been really great talking to you today.
Thanks, Mia. I appreciate it.
And I encourage everyone to take a look at the solar map online at drcog.org and find out more information about the Denver Regional Council of Governments work. And you can also find out more about the Sunshot Solar Outreach Partnerships work at narc.org/solarops. And also make sure to check out NARC's most recent publication, Profiles in Regional Solar Planning, a Handbook and Resource Guide, which provides more regionally focused case studies and a toolkit to get your community started in deploying more solar energy today. Thanks, and I'll see you next time.
Thank you for listening. For more information about NARC, please visit narc.org.